Machine learning is teaching computers to learn patterns from data automatically. Most people use machine learning every day without realizing it. It powers apps, websites, and smart digital services around you. Instead of following fixed instructions, it learns from experience. This makes it very different from traditional programming methods. In traditional coding, humans write every rule manually. In machine learning, the system discovers rules by itself. It studies large amounts of data to find hidden patterns. These patterns help it make predictions or decisions later. Think of it like teaching a child using examples. The more examples you give, the better it becomes. Machine learning works in a very similar way. It improves as it sees more and more data. This ability to improve is what makes it powerful. It can adapt without being explicitly reprogrammed again and again. At its core, machine learning is based on data. Data is the fuel that powers all learning systems. Without data, machine learning cannot function effectively at all. The system looks for relationships inside that data. It then uses those relationships to make predictions. These predictions are not always perfect at the beginning, but they improve as training continues over time. This process is called training a model. A model is the final learned system that makes decisions. You can think of it as the brain of AI. The model gets better the more it practices, just like humans get better through learning and experience. Machine learning mimics this natural learning process, but it does it using mathematics and algorithms. These algorithms help the system understand complex patterns. One simple example is email spam detection. The system learns what spam emails usually look like. It studies thousands of spam and normal emails. Then it predicts whether new emails are spam or not. Another example is recommendation systems. These systems suggest videos, products, or songs you might like. They learn from your past behavior and preferences. This is why your social media feed feels personalized. Machine learning quietly shapes your digital experience every day. Even search engines rely heavily on it. When you type something online, results are ranked using machine learning. The system decides what is most relevant for you. It does this by analyzing billions of data points. This makes search results faster and more accurate. Machine learning is also used in voice assistants. They learn to understand different accents and speech patterns. Over time, they become better at recognizing your voice. This makes interaction feel more natural and smooth. But behind the scenes, everything is based on data patterns. Nothing is truly understood like a human would understand it. Machine learning is not magic, but it feels like it sometimes. It is a combination of statistics, math, and computing power. These elements work together to create intelligent behavior. However, the system still has clear limitations. It cannot think or reason independently like humans. It only reacts based on what it has learned before. If data is wrong, its predictions can also be wrong. This is why data quality is extremely important. Better data leads to better machine learning performance. Poor data leads to poor and unreliable results. Understanding this foundation is very important before moving forward, because all advanced AI systems are built on it. Machine learning is the first step toward intelligent machines. It bridges the gap between data and decision-making. Now we move deeper into how it actually learns from data. Machine learning learns by turning data into patterns and predictions. At the center of this process is something called a model. A model is like a digital brain trained on past data. It learns by adjusting itself again and again. This adjustment process is called training. During training, the system studies thousands or millions of examples. It compares its predictions with correct answers. Then it slowly reduces its mistakes over time. This improvement process is called optimization. The goal is to make predictions as accurate as possible. Machine learning does not memorize data like humans. Instead, it learns hidden patterns inside the data. These patterns help it generalize to new situations. That means it can make predictions on unseen data. This ability is what makes machine learning powerful. There are inputs and outputs in every machine learning system. Inputs are the information given to the model. Outputs are the predictions or results it produces. For example, input could be an image of a house. Output could be the estimated price of that house. The model learns the relationship between both. This relationship is discovered through training data. The more data it sees, the better it understands patterns. But it never becomes perfect or fully accurate. There is always some level of error involved. This error is what helps the model improve further. Machine learning systems constantly try to reduce this error. They adjust internal parameters repeatedly during training. These parameters control how the model behaves. Small changes in parameters can improve accuracy significantly. One important concept is something called a data set. A data set is a collection of structured information. It contains examples that the model learns from. Some datasets are labeled with correct answers. Others contain only raw information without labels. Labeled data is used in supervised learning. Unlabeled data is used in unsupervised learning. Both types are essential in machine learning systems. The quality of the dataset affects performance greatly. Good datasets lead to smart and reliable models. Another key idea is something called features. Features are important characteristics in the data. For example, in house pricing, features include size and location. The model uses these features to make predictions. It learns which features matter most over time. Some features have more impact than others. Identifying important features improves model accuracy. This process is called feature selection. It helps reduce unnecessary information in the system. Less noise in data means better learning results. Machine learning also uses feedback to improve itself. When predictions are wrong, the model learns from mistakes. This feedback loop continues many times during training. Over time, errors become smaller and smaller. Eventually, the model becomes good at predictions, but it still cannot understand meaning like humans. It only works with mathematical relationships in data. That is why it is powerful, but still limited. Training a model can take seconds or even weeks. It depends on data size and system complexity. After training, the model is ready for real-world use. This stage is called deployment. Now the model can make predictions on new data. This is where machine learning becomes useful in real life. Next, we will explore the main types of machine learning. Machine learning is divided into three main powerful learning types. Each type learns data in a completely different way. These types are supervised, unsupervised, and reinforcement learning. Understanding them helps you see how AI actually thinks. Let's start with the most commonly used type first. Supervised learning is like learning with a teacher guiding you. The system is trained using labeled data and correct answers. It learns by comparing predictions with known results. If it makes mistakes, it adjusts and improves. This continues until it becomes highly accurate. For example, email spam detection uses supervised learning. The model learns from emails already marked as spam or not spam. Then it predicts new emails based on that learning. Another example is image recognition systems. They learn by studying labeled images of objects and animals. Supervised learning is widely used in real-world applications. It is popular because it produces accurate and reliable results. However, it requires a lot of labeled data to work properly. Collecting labeled data can be expensive and time-consuming. Despite this, it remains one of the strongest learning methods. Now let's move to the second type called unsupervised learning. In unsupervised learning, there are no correct answers provided. The system must find hidden patterns on its own. It groups similar data together automatically. This process is called clustering. For example, customer segmentation uses unsupervised learning. It groups customers based on behavior and preferences. Companies use this to understand different user types. Another example is detecting unusual patterns in data. This helps identify fraud or abnormal activity. Unsupervised learning is more flexible but also more uncertain. Because there are no labels to guide the system, it must discover structure hidden within raw data. Sometimes the results are surprising and insightful. Other times they may be difficult to interpret. Still, it is very useful for exploring unknown data. Now we move to the most exciting type of learning. Reinforcement learning is based on rewards and penalties. The system learns by interacting with an environment. It receives feedback based on its actions. If it performs well, it gets a reward signal. If it performs poorly, it receives a penalty. Over time, it learns the best possible strategy. This is similar to training a pet with rewards. For example, game-playing AI uses reinforcement learning. It learns by playing millions of game simulations. Each move improves its future decisions. Famous AI systems like Game Champions use this method. It is also used in robotics and self-driving systems because it helps machines make decisions in real time. Reinforcement learning is powerful but very complex. It requires a well-defined environment to interact with. The system must explore and experiment constantly. It balances between trying new actions and using known ones. This balance is called exploration versus exploitation. Finding the right balance is very challenging. But when done correctly, results can be extremely powerful. These three learning types form the foundation of machine learning. Each type solves different kinds of problems. Together, they power most modern AI systems today. From predictions to recommendations, everything depends on them. Understanding them gives insight into how AI truly learns. But machine learning is only part of the bigger AI world. There is still more to explore beyond these methods. Next, we will discover real-life applications and future impact. Machine learning is already silently shaping almost every part of life today. You may not see it, but it is working behind the scenes constantly. From your phone to hospitals, its impact is everywhere. One major application is in social media platforms. Machine learning decides what content you see every day. It studies your behavior, likes, and interactions carefully. Then it predicts what you will enjoy most. That is why your feed feels so personalized. Another major area is online shopping systems. Websites recommend products based on your browsing history. These recommendations are powered by machine learning models. They help businesses increase sales and improve user experience. Streaming platforms also rely heavily on this technology. They suggest movies and shows based on your viewing habits. This keeps users engaged for longer periods of time. In healthcare, machine learning is saving lives every day. It helps doctors detect diseases earlier and more accurately. Medical imaging systems can identify tumors and abnormalities. These systems analyze thousands of scans in seconds. This speeds up diagnosis and treatment decisions greatly. In finance, machine learning detects fraud in real time. It monitors transactions and flags suspicious activities instantly. This helps protect users from financial loss. Banks also use it for credit scoring and risk analysis. Even stock markets use machine learning for predictions. Transportation is another major field using this technology. Self-driving cars rely heavily on machine learning systems. They analyze roads, traffic, and obstacles continuously. This helps them make safe driving decisions. Navigation apps also use machine learning for route optimization. They predict traffic and suggest faster routes. In agriculture, it helps farmers monitor crops and soil health. It improves yield prediction and resource management. This makes farming more efficient and productive. Machine learning is truly transforming every major industry. But with all this power comes responsibility. Data privacy is one of the biggest concerns today. Machine learning systems rely heavily on user data. This raises questions about how data is collected and used. Ethical AI development is becoming extremely important. Developers must ensure fairness and transparency in systems. Bias in data can lead to unfair outcomes. That is why careful model design is essential. Another concern is job automation in the future. Many repetitive jobs may be replaced by machines. However, new jobs will also be created in AI fields. People will need skills in data science and machine learning. Education systems must adapt to this technological shift. Learning AI will become as important as learning computers today. The future will belong to those who understand data. Machine learning will continue to grow rapidly in coming years. It will become more accurate, faster, and more intelligent. New innovations will expand its capabilities even further, but it will still depend on human guidance and control. Humans will always play a key role in shaping AI. The goal is not to replace humans, but to assist them. Machine learning is a tool to enhance human intelligence. When used wisely, it can solve global challenges. From climate change to disease, its potential is huge, but misuse can also create serious risks. That is why responsible development is critical. Understanding machine learning helps us use it better. It is not just technology, but a powerful transformation. The future of AI depends on how we use it today, and machine learning is just the beginning of that journey.